Good morning, good afternoon, good evening, wherever you may be watching this video from. This is Cornelius Tubinza with another video. And in this video, we are going to continue answering the 2024 paper 1 internal additional mathematics question paper. This is question number 10. And it reads, find the vector equation of a line through the points A 3,7 and B 2, -8 carrying 2 marks. Then question B reads, this is B1, B Roman numeral 1. Find the value of t for which the vector p is equal to ti plus 3j, and then the vector q is equal to, I don't know if you can see this, but it's r. Just try to look at it again. Yes, that is r. Oh, that's sorry, it's t. Sorry. T squared I minus 9j are perpendicular, and then 10b2. Find the angle between A is equal to I plus 7j. That's vector A is equal to I plus 7j, and vector B is equal to 2I plus j in degrees. In total, the vector's question is carrying, that is 8 plus 3, 11 marks. 11 marks. Oh, sorry, not 11, it's carrying 9 marks. Pardon me. It's supposed to be 6 plus 3, not 8 plus 3. So 6 plus 3, 9 marks. So just from the total number of marks, we can see that this is a very, very important question for you to know. Question A has various methods, and what can I say? I'm going to share a particular method that you can use for question A. I think I can share about 2 methods which can be acceptable for question A. So this is question 10A. So 10A, we are going to have the coordinates A and B, so A there, B there. Then what was our A? Our A was 3, 7, B was 2, -8. So then we have 3, 7, 2, -8. Write that again. So 2, -8. These are the pair of coordinates that we have. So, well, okay. When they say vector equation, that is, as you can see, 10A, vector equation of the line, what do you need to know? You need to know that for a vector equation in 2 dimensions, in 2 space, x, y, that is writing it in the column vector form. I hope you know this is a column vector. Okay, it represents a column vector, and we usually write the vector equation in the column vector form. So it's equal to x naught, y naught, x naught, y naught representing a coordinate, because a coordinate on the x or y plane starts from the origin, and if we think of it in terms of vectors, vectors that start from the origin are called position vectors. So let me just do this. I'm going to say x, so x, y, okay, is equal to x naught, y naught, then something we call a parameter, which just used to vary. It's just used to vary something called the direction vector, which we call m1, m2. and this is, I said, in the column vector form, right? The column vector, the column vector form. I know maybe everything I've said is confusing, so to simplify it, I am saying that here at the left side we have the column vector x, y, okay, representing or showing us that we are finding the vector equation of the line. And then I said x naught, y naught, this one right here, it represents what we call the position vector. Okay, so I'm going to say position vector. And then I said this one is called parameter. Just, you can say a parameter. It's just used to vary, okay, vary the direction vector. Direction vector m. That's all that the parameter does. And then since we're representing the direction vector m in form of this particular column vector, this which we have remained with is the direction vector. Okay. Oh, I've run out of, oh goodness, what have I done? I've cleaned out what I wrote. Okay, anyways, I know what I'll do. So there we are calling it the direction vector. Is that readable? Let me just remove that once more. It's not looking. So direction vector. What is the direction vector? Showing the direction of the vector from the name. Okay, so just want to give a small background so that as we start answering this question we know what is happening. So this one varies the direction vector. Very important to know. So this can be even written in a simplified form where it comes from the vector r is equal to we have the vector, the resultant vector r is equal to the a certain position vector r naught, right? And then plus t, which is the parameter direction vector m, and then you go to what I wrote, which was writing it in the column vector form. So this is where it's it's kind of originates from, but this is the particular vector equation we're considering. Okay, so from there let's answer. How do we find the vector equation? You can use two methods like I said. So because I've spent some time explaining there, I'll just hurry up in my explanation. So I have method 1 here. Method 1, which will be like this. So you have coordinate A, which is 3, 7, and then B, which is 2, -8. I hope you took note. So what you can say is we can write A and B in the position vector form. We'll say OA is like that, in the form of a position vector. So since we're saying so nothing is changing, I'm just writing it in the form of the column vector, right? This is a column vector. And then OB is equal to 2, -8. Then how do we find the resultant? The resultant is the direction from A to B. Direction vector AB is equal to AO. So we are going to go from A to O. Okay, A to O. Then we're going to go, we are now at O, right? Now from O, we're going to go to B. Okay, A to O, O to B. As we know, A to O is in the reverse direction. It means we have to include negative signs. O to B, we'll just leave O, B as it was. Then we add them correspondingly, or let me say simplify correspondingly, where we are going to end up with, we look at the X, we look at the top, the X values. -3 plus 2 is -1. -7 plus -8, you're going to have a negative what? 15 as your A, B. So you have your -1 there, and then you also have your -15. And then your vector equation, it will be xy is equal to a position vector, right? Position vector can mean any coordinate that is on the line. We know both A and B are on the line, so you can say this, which is 3, 7 plus parameter t multiplied by -1, -15. That's it. Or you can also say vector equation x, y is equal to, the position vector. Now we change from 2, is it -2? Let me just try to confirm. 2 -8, yeah, 2 -8, like that, plus the parameter t multiplied by the direction vector, which is -1, -15. And that will be it. So you can have those two answers. And that's it for method 1. We go to method 2. That was under method 1. Then, so you can pick whichever method would be comfortable for you. Method 2, where we'll have something like this. We have x and y. So we have coordinates A and B, which is 3, 7 for A and 2, -8 for B. And how do we simplify this? We aim at finding the gradient. Okay, our aim is to find the gradient, where I will say m is equal to y2 minus y1. You divide, so which is the y step divided by the x step, okay, which is going to be equal to, so in naming your coordinates, it will be alright. You can start with A or B, but don't worry, maybe if you name your coordinates and then your direction vector, this part here having t has positives throughout, it's okay. Okay, so long as it has positives throughout, then it's the same answer. I hope that is well noted. Then we have y2, which is -8 minus 7. So we have -8 minus a positive 7, so it's just -7. And then x2 is 2 minus 3. So we have a 2 minus 3, like that. Where we are going to have is equal to negative 15 divided by negative 1. Okay, let me write that again. Negative 15 we divide by negative 1, and then at this particular stage, this is our m, this is our gradient. So don't simplify anything because you might distort your final answer. Just leave it as it is with the signs that it is, then you flip it. Okay, so you're gonna do that, you're gonna read it in that way, and then upon you flipping it, it's going to become direction vector m is equal to negative 1, negative 15. After finding direction vector negative 1, negative 15, it means that x, y would be equal to any position vector of your choice. I'm going to use 3, 7, and then plus t, and then here we have a negative 1, 15. Okay, so we have a negative 1, 15 right there, like that. Yeah, so then you can conclude that therefore x, y is equal to 3, 7, plus t, and then you have negative 1, negative 15. I forgot to put negative 15. Let me just write this: negative 1, negative 15, like that, in the column vector form, and that would be a final answer. Here is supposed to be a negative, just take note. Yeah, so that's your answer to A. In-depth explanation of things you need to know. Yeah, so these are two methods to what? But these are just two methods to find the direction vector, because no, finding the position vector is not required, it's given in the question. It's just a point along the line or on the line AB. So we are done with question A. We go to question B. Find the value of t for which vector p is equal to ti plus 3j, and then vector q is equal to r squared I minus 9j are perpendicular. Are perpendicular. And this is carrying, let me just try to see, 4 marks. 4 marks, my goodness. And I want you to find the value of t. So what do you need to know? What do you need to do here? How do you even start answering here? So let's just take note that they are perpendicular, and then we take note that vector p is ti plus 3j. So vector p is ti plus 3j. Then vector q is t squared I minus 9j. Okay, so p is ti plus 3j. So this is bi, where vector p being equal to, say, ti plus 3j, and then vector q being equal to t squared I. No, I remember them very well. Minus 9j, yes. So vector p being equal to that, vector q being equal to that. I hope you can see that. Can you see that? So that's vector p, vector q. The two vectors are perpendicular. Why is that so? This is because when we are considering the dot product of two vectors, the product of two vectors, let me simplify, let me say it like that. We are considering that we say that, for example, let's consider the vectors. So we say consider the vectors A and so we consider the vectors A and B. What do? We have to know that cos 90 degrees, if they are perpendicular, the formula of the dot product is given by, so this is the formula. This is the dot product in 2 dimensions. So the formula is given by A dot, from the word, from its name, A dot B, just means A times B is equal to the magnitude of A, magnitude. Okay, so I've been looking at magnitude. We need to know magnitude is represented by 2 bars, modulus, multiplied by magnitude of B, multiplied by a cos theta, where we have to know that for us to have A dot B equal to 0, so we can have a certain magnitude there, multiplied by a certain magnitude there, multiplied by a cos 90 degrees. Now if you look at the parent graph of cosine, at 90 degrees, cos is going to cross the x-axis. So the angle at the value rather at 90 degrees is going to be 0. So no matter what we have, since we are multiplying by 0, A dot B is 0. So why did I do all this working? This is just to familiarize you. And then we'll say Ti plus 3j. Okay? So we know from the working that vector P times vector Q is equal to 0. And then we have Ti. So Ti plus 3j, okay, times Q, which is T squared I minus 9j is equal to 0. And then we have to know a certain rule that when we're multiplying vectors, we should be multiplying this one and that one, and then this one and that one. Why? Because we need to know a certain property that I squared is equal to 1, and then we're going to have j, that's alright, j squared is also going to give you a value of 1. So you need to know I squared is 1, j squared is 1.
On top is red.
And then after knowing this, we also have to know that I, so last thing to know is just I times j will give you 0. So as you are multiplying, just multiply them the way I've underlined them. So I'm going to say Ti times t squared I. We're going to just have t cubed, because I times I is 1. I hope I haven't lost you there. So t cubed. And then we're going to have 3j multiplied by negative 9j. It's going to be negative 27j squared, which is just negative 27 times 1, negative 27. So minus 27, which is equal to 0. To find the value of t, we're going to say t cubed is going to be equal to 27. And then we cube root both sides. Simply cube root. So we're going to have t is equal to, what's the cube root of 27? Simply 3. So therefore t is simply equal to 3. That's your final answer. You get your 4 marks. Just have to show your working, and yeah, that's it. 4 marks there. So this is our last question for the video. It reads, this is 10b2. Find the angle between vector A equal to I plus 7j and then vector B 2I plus j in degrees. So how do we go about this? So let's start by writing what we know. So vector A is I plus 7j, vector B is 2I plus j. So we have answered these two questions. This was very short working, but I'm answering on each page just for neatness sake. Okay, so we're going to say vector, first of all, let's write B2. So upon us writing vector, we're going to say vector A is equal to something, then vector B is also equal to something. So what was our vector A? Our vector A, hope you remember, I plus 7j, hope you saw that. So we have I plus 7j for vector A. Then we have our vector B. Vector B is 2I plus j. So that's your vector A, that's your vector B. Vector A, I plus 7j, vector B, 2I plus j. I want you to find the angle between these two vectors. So for you to find the angle, you need to know the formula for the dot product, the one which I gave previously. So if you have two vectors A and B, we said vector A dot vector B is equal to the magnitude of vector A multiplied by the magnitude of vector B multiplied by a cosine theta. Alright, so we have the formula. Now how do we even go about the working? So we write vector A, which is going to be the product of I plus 7j is A. That's vector A, then vector B is 2I plus j. Oh, look at that, I've written the I. 2I plus j is equal to magnitude of A, magnitude of the vector. I hope you know how to find it. It's just the square root of the x component plus the y component squared. Take note, I said I squared is 1, j squared is 1. So it's like the square root of, let's look at vector A, which is I plus 7j. So the square root of 1 squared plus 7 squared. That's the magnitude. Then multiplied by the square root of 2 squared plus 1 squared. Multiplied by what? Cosine theta, because we are looking for the angle between the vectors. And then this side, I said we need to simplify. How do we simplify it? I explained. We multiply the i's and the j's together. So writing it nicely for us to understand, we have to write it like this. So I will go with the I, and then the j will go with the j, where we know that I squared is equal to 1, and we know that j squared is equal to 1. Then we can work around that. I times 2i, we're going to have a 2, and then this side we have 7j times a j, you're going to have a 7. 2 plus 7, simple as that, is equal to the square root. So it's better I don't simplify this. So the square root of what? So 1 squared plus 7 squared. 7 squared is 49 plus 1 is the square root of 50. Times the square root of, this side you have 2 squared, 4 plus 1 is 5, square root of 50 times the 5 times the cos theta. At this stage we divide both sides by this square. We want to leave the square, the cos theta on one side of the equation, so we divide by this. Divide by square root of 50 times square root of 5, in order to give us a 1. Then I'm going to have cos theta being equal to 2 plus 7 is a 9 over the square root of 50 times the square root of 5. So the answer that we get, we don't even need to go to quadrants. The answer that we get would tell us the quadrant in which these vectors are. So even if it's positive here, as you can see, there's no need for us to start going to the fourth quadrant. No, we just get the answer that we get. So cos inverse of 9 equals 2 plus 7 square root of 50 times the square root of 5. I hope by now we have experience, right? We know how to type this into the calculator. Yeah, if you don't know, that's a pity, but you need to know. Make sure your calculator is in degrees, because this is a question paper which has radians. So cos inverse of 9 divided by the square root of 50 times the square root of 5. The square root of 50 times the square root of 5. Let me just try to type that into my calculator. Cos inverse of 9 divided by square root of 50 times square root of 5. I'm going to have a 55. So all angles in the beginning of the paper you correct to 1 decimal place. So 55.3 degrees, and that is the angle between the two vectors. That is your theta. Oh yeah, you can just say that's your theta as your final answer. I hope it's clear. If there will be any queries, you can drop it in the comment section. This has been Cornelius Tuvinda representing ZSTEM Hub with another video, and bye bye.